This is Anthony Karlstrom. The date is March 30th. The lesson plan I'm about to present is on the triangle sum theorem. The goal is to have students understand the sum of the interior angles of a triangle equals 180 degrees. And this lesson plan would be adaptable for students between 5th and 7th grade, depending on their entry point for studying geometry. All right, here we are. Here we are today, guys. Who's ready to learn a little bit about geometry?
Yeah.
All right, okay, cool. So today we're going to learn about is the idea that the sum of the interior angles of a triangle equals something that is consistent. And we're going to talk about what it is, and we're trying to get there by doing some math, okay? So first things first, we're going to answer the question today, can the angles of a triangle form a straight line? Do you guys think that's possible based on a triangle?
No.
No, probably
Well,
not.
no, maybe.
Maybe.
Oh, yeah,
Maybe? Okay, so what we want to do then is try to figure out a way to see if we can make this actually happen. So let's go about the first few things we know about triangles. First of all, what do we know about triangles in general?
that there are three types.
Well, there's lots of different types.
Three types,
Three
but
types.
well, there's six if you count right up to and cube.
Okay, so we have right up to, so acute triangles. Okay, what else?
Isosceles,
Isosceles.
equilateral,
Okay,
and
oh yeah.
what's the other one?
I don't know.
Scalene.
Scalene, okay, cool. And what are the attributes of triangles? What are the things that make a triangle a triangle?
So
Yeah.
it has three sides.
Three sides and what?
They have
1, 2,
angles.
3 sides and 3 angles. So that
Yeah.
makes you get a triangle. The word tri means three
angle.
and 3. There we have 3 angles and 3 sides. Okay. So we know a little bit about triangles, and we also know a little about lines. What is the measure of degrees inside of a straight line? Nancy? 180 degrees. Okay. So here we have a triangle, and then we have a straight line. Could a triangle come together and have the angles form a straight line? Do we think it's possible?
Yes.
Yes?
Yes.
Yes?
Yeah.
Yeah? Okay, all right. Well, we probably can do it. Let's figure out how much they actually measure when we come together and do this. What we're going to do here is we're going to get a series of pre-cut triangles, okay? I want you guys to look at the triangles, and I want you to keep them on the big side facing towards you, okay? So the base side down, okay? So I'm going to give you a triangle. They're all the same. All three are the same triangle, okay? What I'm going to ask you guys to do is to not flip it over, okay, and take your triangle like you have it right here and fold the top angle to the tip of that triangle. Tip of that angle touches the base, and then make a nice crease, but you want to make sure that this line, the crease here, is parallel to the base, okay? All right? So make a nice crease there, okay? Yep, that looks pretty good. And what number do you see pops up there? 90. Everyone got 90? Okay, so these are pre-measured. Now what you're going to do is you're going to take the other triangle, right, the other angle right there, and you're going to fold it in to meet that point right there. Okay, so take the other angle on the right or left, and fold that in right there. Okay, and then take the third one there and fold them in. Okay, so what we have here is 3 angles that are meeting up. Okay, in other words, they're coming together. And what shape do they form? That looks pretty good. That looks pretty good. Keep trying to fold it. Oh, that looks pretty good.
But mine's
There you
twisted
go.
like this.
Yep, that's folded like that. You want to take this one and bring it in. Well, hang on. We'll get there.
I folded mine like this.
Fold that like that.
I
Okay.
turned it into a sign.
Okay, hang on. We gotta readjust it. We gotta fold it this way. Okay. So let's talk here. The angles were pre-measured, and they formed a straight line. What were the measure of the angles that you have in front of you right now? Leo?
90,
90,
31,
31,
and 59.
and 59. Okay. And if we added those numbers together, 90, what's 31 plus 59 equal, Leo?
90.
Equals 90. 90
No,
plus
80.
90?
That's 80.
Well,
One
actually
plus
it's
eight
90.
is
You're
okay,
better
yeah,
there.
that's 90.
90 plus 90 equals
180.
100.
Oh, that tells you
80.
that when you fold all your sides in,
Uh-huh.
every single time they always equal 80.
Well,
100.
this time they did, okay?
Yeah.
So let's try with a different triangle and see if it's the same thing, okay? So we want to repeat things to see if things are actually true when we do geometry. So this one right here, We added up the angles here and they equaled 180 degrees. They formed what shape is this, kind of?
Square, like half a circle.
Half a circle. What do we call that?
Versus 1/2.
1/2,
Semicircle.
Semicircle,
Semicircle.
okay, alright. New triangle, same way, put it on the base, okay, and don't fold it yet. What I want you guys to do is, again, this time try it a little bit better because you did it once. Take the top of that one, fold it down, make a nice crease, make sure that these sides are going to be parallel, okay? Then fold your other sides in to equal that as well, alright? And you're going to have 3 angles meeting up, okay?
It's a rectangle.
And it does form a rectangle, doesn't it? It looks like everyone formed a rectangle when they did that. I have a pretty good rectangle, okay? So, with this one, there's also pre-measured angles right there. And what are the measure of the angles this time?
59, 60, and 60, and
All right.
61.
Okay, hang on. Everyone get there? Did you get there? You got there? You got there? You got there? Okay, cool. So we have 59, 60, and 61. And we know 59 plus 61 equals
Right. Well, wait. That.
that plus
I know.
Whoa,
That's
let's
60
sit.
plus 60. That's 60 plus 60 plus
60 plus 6 plus 60. 61 plus 59 is 120 plus 60,
You can take that one.
180. Good. We borrowed this guy and put him over here, didn't we? Okay, so twice now we have found the measure of these angles to be how many degrees?
180.
And what figure did they form? Did they form a
Rectangle.
rectangle? But when the angles come together, they form a
Semicircle.
semicircle, which has a measure of what? 100 degrees. And it forms a straight line also, which has a measure of
180.
180 degrees. Oh my God. Okay, so let's try this last one here. This one we're going to kind of write a general statement for. So put this away. Now you should be getting pretty good at making these rectangles, base side up with the clear side facing the top here. Okay. One more time. Let's fold our triangle. Okay. And this time you're going to see that there's actual letters. I'm not going to measure just yet. So bring your measurements down, your angles down, like we've been doing. And what letter appears there at the top?
A.
Okay, so angle A. Okay, angle A. And anyone have the second one on there
B.
connected? What angle is that? Angle
B.
B. And then that's the third one.
Angle C.
Angle C. Angle C. Well, what do we think angle A plus B plus angle C equals? Ava?
Angle B.
Well, angle A plus angle B plus angle C, if you look there, you have the answer right in front of you, right?
BAC.
Well, BAC, but what's the measure? We add those 3 angles
100.
together. 180?
I think so. No.
Well, what do you think? You have the answer right there. You
It's
added
right
the
here.
3
It's
angles.
right here.
It's right in front of you, right?
Yeah.
When you add those 3 angles together, they come together and they form a straight line, correct? Okay, so what do we think the measure of angle A plus B plus C is? Again, Leo?
60.
60?
No.
Angle A plus angle B plus angle C is going to equal how much? 180 degrees. Okay. All right. So now we're going to test our theory, okay? We are going to quickly measure each of these angles, okay? Using, oh, you overcrossed it, okay? Using our protractor, okay? Now, that's okay. We're getting pretty good at protractors, but let's just kind of real quickly go through it as a group because we're running out of a little bit of time today. So angle B, if I were to measure it, angle B measures about 53 degrees. So we're going to write that on the board here. Angle B is 53 degrees. And you can try to measure it as we go along here. We want to kind of pick up the pace. Angle A measures, oh my, angle A measures 90 degrees. Okay, so we're going to put that down right there. So what's the measure of angle A plus angle B right now? Leah? 90 degrees?
No, 143.
143, okay. And what's 143? 180 minus 143. Let's do that problem real quick on the board here.
So you have to borrow.
We'll borrow,
That
make that a
becomes
7.
That becomes a 10. That's a 7.
7, then
Then
37. You guys get 37?
Wait,
So do you think
that means
angle
that
C is
C
37 degrees?
37
Well, let's just check and make sure. Let's see. So we're going to get our protractor here out, and that is spot on 37 degrees when we get there. Okay, so now we have 3 angles which when come together equal 180 degrees. Okay, so were we able to first of all bring the angles of a triangle to form a straight line?
Yes.
And what was the sum when they came together? Ava?
180 degrees.
Oh, hey, 180 degrees. Okay, cool. So you think this is true of all triangles? We did it for 3. Is it true of all triangles?
No.
Oh,
yeah.
Well, yeah.
More than likely. So at a certain point in time, once we've established a pattern, once we've established an idea, and we see that it's consistent, and we can measure things over and over and over again, what we come up with is a theorem. So what we've established today is the idea of what's called the triangle sum theorem, okay, which kind of restates our idea from the start of class. The triangle sum theorem states, what do you think it says? It says something about the sum, oh, Leo, the sum
The sum of
the
triangle,
of the triangles
Triangle.
what?
triangles,
Area?
no,
No, not
No,
area.
lines?
No. What were we measuring? We were measuring
Perimeter?
No, angles.
the angles,
The angle.
the interior angles equals how much? Equals what?
Usually
180
somewhere around
degrees.
180.
Somewhere around there, or
Well, it's usually
Always
like
100.
okay, usually,
Not
okay,
all.
equals 180 degrees. Good. And that's what's called the triangle sum theory in our own words. So we did a really nice job of picking up that concept right there. So what if, here's a question for you guys. Moving forward, if tomorrow I said to you, let's take a rectangle and figure out how many degrees are in the rectangle, you might already know. But how could we use this idea to find the degrees in a rectangle? What is a rectangle made of?
Oh.
Leo?
Right angles.
Well, it's got right angles, true.
Yeah, it has
Ava?
4 lines.
4 lines. This is kind of tricky. It's something we don't think about all the time.
Two sides are parallel to each
Yeah,
other.
that's true. Those are all the things that make up
Kind of
rectangles. Yeah, yeah. The thing that makes up a rectangle, and we're getting all kinds of ideas, is 2 triangles. So what's the measure of the angles inside of here?
360 degrees.
Well, wait, this
No.
one's 180,
180.
180 plus 100.
and this guy right here is,
180.
That's 360.
and we have, okay, so you think the whole side of here is 360.
360 degrees.
Yeah.
Very possible. And that's where we'll probably pick things up tomorrow. So our lesson today has been all about, again, the idea that inside of a triangle, the interior angles equal 180 degrees. They're what we would call supplementary. They form a straight line. And we also can take our idea and move forward as we learn about rectangles in the next few days. So good job today, you guys, and we will come back to this tomorrow. All right? Thanks.